Hello everyone, my name is Colin Greatwood, Mechatronics Technology Engineer with Festo, and I'm here today to showcase how to network a Siemens PLC over Profinet with a MURR Electronic Pro Remote IO block, version 54610, and an SMS Festo Simplified Motion Series Actuator, the EPCE. So to get started, I'll first open TIA Portal. I have version 17 here open. First I'll click Project and New. I'm going to create a simple project here in my Downloads folder. Now I'll create my project. Now that I have a new project started, I need to add my devices. Here in the device view on the left side of your screen, you can see that I have a simple 120 volt VAC power supply coming from the wall and converting to 24 volts DC. That's powering a Siemens 1200 PLC, a 1212 FC DC-DC relay. I also have a Netgear 5-port switch, a MURR Pro module, remote I/O module that's capable of Profinet on the field bus side, and standard I/O or IO-Link on the device side. And there are 8 ports, and I'm only utilizing one of those ports here today. And last but not least, a simple Festo SMS EPCE actuator. So let's get started. So the first device that I'm going to add, since I'm starting this project from scratch, is the 1212 FC DC-DC relay Siemens PLC. You could certainly start this entire procedure by downloading the standard sample file from the SMS landing page, but I'm going to be building it from scratch very quickly. Now that I've got my PLC added, I need to set the Ethernet address for that device. Under the device view, I'll click on Properties, go to the General Properties, and then assign a static IP address under Ethernet addresses in the Profinet interface of 192.168.0.1 with a subnet mask of 255.255.255.0. Now I'll go back to my network view, and I still need to add the MURR Remote IO block 54610. In order to do that, I'll have to download the GSD file from the MURR landing page. The simplest way to get to this is by typing in MURR or MURR Electronic and then the specific article number, which is found by looking on the physical unit, 54610. I'll click on the landing page for that device. Once I come to the landing page, I'll double check that this is the device that I'm using. You can see that it looks identical to the one in the screen. I'll go down to the Downloads section, and underneath this you can get a number of useful tools as well as the description files here. Configuration files GSD.ml. I'll click Download, Acknowledge, and download that description file. I'll extract this here in my Downloads folder. And now in TIA Portal, I'll go to the Options menu, Manage General Station Description Files, select the extracted folder from the downloads, and under GSDML folder, the subfolder, you'll find a single file version 2.35 currently that needs to be installed. You can see I already have it installed here, so I don't need to do that. Now in the hardware catalog, you can go to find MURR product 54610. It's under Other Field Devices, Profinet IO, IO, MURR Electronic, and under the Pro modules, not the standard modules, you'll find 54610. You can double click that or drag it into the project. Now I'll network this with PLC 1 by clicking and dragging that to assign the MURR block to PLC 1. You know it's assigned when you have PLC 1 listed underneath the name, and you can see the network matches the PLC's name. Double click on the Pro module, and now we will set the IP address of the module by clicking on it once in Device View, going to the Properties, General Properties, down to Ethernet addresses under the Profinet interface, and you can see it auto-assigns to the next available IP address, 192.168.0.2, with the same subnet mask as the PLC. The next thing we need to do is add our devices to the specific channels within the MURR block. I'm going to expand this so we can see. Just like on the physical module, you can see there are 8 ports. They're labeled X0, X1, X2, X3, X4, X5, X6, and X7. Our device, as you can see, is connected to X0, and the SMS actuators consume 3 bytes in and 2 bytes out, so we'll need to add a submodule that consumes about that or more. Underneath submodules, you'll click Generic IO-Link Devices, Generic Input and Output Devices plus a PQI byte. And the closest thing to our device is going to be 2 bytes in, 2 bytes out, plus a PQI byte. Click and drag that to slot X0. Notice that the addressing allocates 4 bytes in and 2 bytes out. 2 bytes out was expected. 4 bytes in is somewhat unexpected, as we will only be utilizing 3 bytes in. This is due to byte boundaries in TIA Portal, but it will not affect any of the function for that device. For the rest of the ports, as you can see, nothing is connected to them. I will click and drag a deactivated port identifier to each of those remaining ports. Now that we've got deactivated on all other ports, the last thing that's a very useful tool is to add a web server for diagnostics and configuration to the option ports below. Now that you've got all the remaining ports assigned as deactivated with no device connected, there is one option that is very useful to have for diagnostic and configuration, and that is an available onboard web server, which can be accessed from any standard web browser. You'll find this by going to the MBK Pro Options tab on the right under the Hardware Catalog, going to General, and then Web Server. As you can see, when I click this once, there is a default port or slot that is available to be dragged to, so click and drag that to slot 27. Now that we've got our entire network set up and the specific slots on the MBK Pro module assigned, we can compile, download, and go online with the PLC. Okay, you know you're online with the PLC when you have all green circles on the left-hand side under the project tree. And you can see here my program blocks, my standard program blocks, the safety administration, and all of my distributed and local I/O is all green. So this means I've performed my networking correctly and I've added the correct modules and it's detecting the correct devices. The next thing I need to do is add to my main OB1 the standard function blocks available with the SMS actuators from Festo. I'll expand my program blocks, go to main OB1 by double-clicking. In order to add the standard function blocks available from Festo for the Simplified Motion Series actuators, I'll have to go to the landing page for the specific actuator. By looking closely at the label on the side body of the actuator, you can see that the specific numerical part number for this is 8102168. I'll open Google Chrome, go to Festo's landing page. In the search bar, I'll type in that part number for the specific product. Once I'm on the specific product's landing page, go to the Downloads tab. Click on the Expert Knowledge and scroll down until you find the application note noted for Simplified Motion Series Control with Siemens PLC through Festo CPX API. Click Download. Once you've successfully downloaded the application note, open that application note and extract it. Within the application note folders, you'll find 3 subfolders. The first is an application note talking about the setup that you've seen so far. The second is the library that we're going to be using. And the third folder is a sample project similar to that which we're putting together. Within the library subfolder, double-click, keep going. Now you'll find a TIA portal library with extension .al14. In TIA portal, click on the Libraries tab on the far right. Then under Global Libraries, select Add New Library. Navigate your way to the Downloads folder you just extracted into. And press Open. Once you've started opening this library, there will be several prompts to upgrade from that version. The original SMS function blocks were released in version 14. I'm using version 17 of TIA Portal today, and I'll need to upgrade those function blocks to version 17. Once the library has been successfully upgraded from its original version 14, which you downloaded from the website, it'll now be available in version 17. And you can see that here under Global Libraries, SMS Festo Library version 2.3, version 17. Expanding that library, I'll be able to add 4 function blocks to my main program. Today I'm going to be using the advanced function block for specific features down the road. If I expand all of the subfolders, you'll see that there's a Festo Advanced function block, a Festo Basic function block, Festo Intermediate function block, and Festo IO function block. I'll click and drag the Festo Advanced function block onto my main rung, Network 1. Now I have my SMS Festo Advanced function block added to network 1. I'll need to add input and output tags to each input and output for the function block. It's very important for the cyclic data, the process data, that your ref inputs and ref outputs and by device available bytes be correct. So you'll need to look back at your device and network view. Under the device and network view, click the MVK Pro module. Within the device view, you can see that the IO-Link port 0 starts at input addressing 3 and output address 3. For the ref input, you'll need to add the second available input byte. Since we started at 3, that will be input byte 4. And for by device available, that'll be input byte 5. Remember that input byte 3 is reserved and input byte 6 is not used. That's just there and allocated due to byte boundaries in TIA portal. For ref outputs, that will also be the second byte of the output assembly. Which was QB4. Output byte 4. Output byte 3 is still reserved. Everything else you can address as per the application note, and I'll do that quickly here. Once you've got all of the input and output tags assigned properly to the data block, you'll need to recompile and download that new code. Now, in order to test the SMS actuator and ensure that it's properly connected to both the process data, which is cyclically processed, and the parameter channel, which is acyclically processed through this function block, I'll add a watch table with the proper sequence. Now I've opened my first watch table, which I've pre-set up for the sequence that I want to execute here today. There are 3 parameters that are very important for processing parameter channel data, and they're right here at the top under established communication parameters. The first 3, hardware identification, the ICAP, and the iPort. I'll start with the hardware identification. The hardware ID, which you can see here on the advanced function block, right next to ICAP and iPort, the hardware ID is an identifier that tells you which device we're trying to communicate with. There are 2 types of hardware identifiers, an IOLM for master and an IOL and an IOLD for device. If you want to communicate with several devices on one MURR Remote IO block, you can do so by using the hardware identifier IOLM. This is only available for Pro modules. For all standard modules, and if you want to communicate with a single device on an IO-Link Master Pro version from MURR, you'll have to use the IOLD for the specific channel. You can find these by going back to the device view for the MURR block. So I'll open the device view, and if I want to communicate with all devices at all ports, I'll choose the IOL or IO-Link Master proxy, available by clicking the SIO slot, pulling up the properties, and under System Constants, you'll see one hardware identifier, 278. I'm only using one device here today, but I'll show how to use this IOLM or master proxy first. So 278. If I go back to my watch table, I'll preload the value 278 under hardware identification. The second piece of information you'll need is the ICAP. This is a vendor-specific number that's released from the IO-Link organization. There are 3 IO-Link caps, iCaps, for MURR electronic. Those values are 255 decimal, 227 decimal, or 46080 for newer versions. You'll see here that I have 46080 preloaded in decimal form. It changes over due to the formatting. If you have it in unsigned decimal format, it'll be 46080. The last piece of information you'll need is the I port. Since I'm connected to X0, you'd think that I would put in a 0 value here for I port. For all MURR standard and Pro Remote I/O blocks, the port numbering that's on the physical unit is not what you'll put here. Port 0 or X0 will actually be I port 1. So this is a 1 base index, not a 0 base index. So I have all of these preloaded. You'll also see I have a sequence here for enabling the function block, supplying load power, not logic power, but load power to the unit, some initial parameters, saving those parameters, referencing the actual servo unit inside the stepper servo unit, and then executing in and out motions. In order to do this, I need to put my PLC into run mode. You can do this from the testing tab on the far right. It'll prompt you to say, are you sure? Yes, we are. Next, from my watch table, I'll preload the communication parameter information as well as enable communication from the block. Now you can see we're starting to get a little bit more information. The next thing I'll do is see and confirm that my function block is enabled, which it is. Next, I'll supply load power, and you'll hear a small hum occur on the drive if you're paying attention. Next, I'll preload values for speed, force, and in position, as well as start press position. I know that my EPCE has 30 millimeters of stroke, which is why I've put in 30 right here. Next, I'll toggle my XStore parameters. This should not be left on. So I'll store my parameters once and then turn that back off. Next, I'll check and make sure my state up device is true. If this does not come on true, or you get a state in and state out at the same time, you may need to reference your device. You'll see in the video that it's referencing and then returning to the previous position. You'll also see from my process data that X state out changed. Now I can enter normal function. I have no errors and I can move in and move out at will. Well, there you have it. Now we've confirmed we have both the process and parameter channels enabled. We confirmed that we had the process channel enabled by getting the X state in, X state device, and X state out bits true or false depending on the current situation. We also tested that by utilizing the X move in and X move out bits, which are processed cyclically. We checked the parameter channel by changing our by force, speed in, speed out, and our positions for in position and start press position to 30 from 0. Thank you very much for your time.